Okay, Unit 4, Lesson 5. We're solving any linear equation now. So we're going to get ourselves a little bit closer to starting to solve our own equations beginning to end. So the first thing that we're going to do is you're going to take a minute and look at these equations and solve them mentally. Okay, so number 1, 2, 3, and 4, you're going to take a couple minutes, pause, and determine the value of x for each one mentally. No solving anything on paper. You can do solving in your head, but without showing any work. Mentally determine the solution of each of those equations. So push pause to figure that out. Okay, so you should have got x equals -3 for the first one, x equals 1, x equals -3, and x equals 2. So the next thing you're going to do is you're going to take a second and you're going to answer a couple questions about how you came up with those solutions. Okay, so what you're going to have to do is I want you to describe how you determined the solution for each. I need a new pen. So take a second and write down by each equation how you determined the solution. Now, if you were wrong, you need to make sure you have the correct answer written, and you're going to come up with a way that you could have arrived at the correct solution now that you know it. So think about, now that you know the correct answer, how could you have done it mentally? So pause and take care of that. Now, if you're struggling a little bit, some ideas, if you look at number 1, that might have been a little bit trickier because 5 minus something equals 8. And if you think about it, if I have 5 and I'm subtracting something, usually when you subtract, you get less. But in this case, after we subtracted, we actually ended up with more. The only way to subtract and end up with a bigger number is if you subtracted a negative. So positive minus negative gets you a larger number. And the reason is, if you remember when we were talking about subtracting is the same as adding a negative, if I were to have 5 minus -3, so if I just substituted for my x, keep the first number the same, change subtraction to addition, and then the next number becomes the opposite, you actually get 8. So subtracting a negative number makes the number get larger, because when you subtract a negative, you're really adding. So that's just a little side note. So when you talk about how you could arrive to -3, you could say, well, I know I had to subtract a negative number because subtracting a negative is like adding. And 5 plus 3 is 8. So since, if you think about it, 5 plus 3 equals 8. The only way to turn this into +3 is if x is negative. That might make sense, that might not. If it doesn't make sense, you've got to find a way for yourself for it to make sense. Don't put what makes sense to me. You need to put what makes sense to you, but it's got to be mathematically correct. So you've got to get notes or write some sort of explanation for each of those. So pause if you have to and do that. Now the next section, 5.2, is an in-class activity with partners. If without the partner part, we're actually going to work on this a little bit differently. So this is the Gold Solving Equations worksheet. So this worksheet right here is where we're going to go next. So make sure you have this worksheet up. Sorry, let me get it zoomed here. Oh, goodness. Sorry, guys. All right, let's try that. Okay, so we're going to begin solving these equations, and you can solve these just how I do. You can, if you see a step that you would prefer to do whatever you would like, make whatever choice you want to make as we solve these. The only thing that has to happen is you have to be mathematically correct, and the choices you make have to make mathematical sense. For example, if you add something to the left, you've got to add the same thing to the right. If you divide on the left, you have to divide on the right. So those mathematical requirements have to happen. But for example, with number 1, okay, we'll start here. So if we look at number 1, I have negative 6x minus 7 equals 4x minus 2. So what I'm going to do, because I like the hangers, and I think a lot of people seem to feel like it makes sense when we see the equation solved on a hanger. But we do need to start practicing transferring what's happening on the hanger to what's happening on the page. So for this part, we're just going to take a minute and just this first one, just to get the kind of the hang of it again. I'll solve the first equation on a hanger, and then we'll transfer our work over to the side here. Okay. All right, so oops, let me try this again. So if I were to draw what's happening on this hanger, on the left-hand side, I have 6 negative x's. So I'm going to do this. So I'm going to draw 6 negative x's, and 7 minus 7 is 7 negative whatevers, whatever we want to call them, like negative units, maybe. Now, just for space purposes, I'm realizing I'm running out of room, so I'm going to write these kind of like this. Okay, so these are my negative 6 and my negative 7. Negative 6 x's, negative 7. Okay. Now on the right-hand side, I have 4 positive x's, so I'll use this green for positive. So I have 4 positive x's, and I have 2 negatives. Okay. So again, here are my 6 negative x's minus 7. My right side, 4x minus 2. So as we want to start balancing this hanger, something to remember, the ultimate goal when we find a solution is the variable on one side and the number on the other. So the ultimate goal is to have variable equals some number, right? That's what we want to happen. Variable equals a number. That's our goal. So as of right now, I have negative x's on one side and positive x's on the other. So I want to get just x's on one side. So we're going to get rid of all x's on one side. But we have to remember that to use the math rules. So let's say that I want to get these negative x's off of the left side. Well, the thing is, I don't have any negative x's here, so it isn't like I can just take x's from each side. It's not going to work. I can't take a negative from here and a positive from here. If you think about these as numbers, if that's negative 2 and that's positive 2, taking a negative 2 off of one side and a positive off of the other, I'm not taking the same amount. Those are different amounts. If you have negative $2 in your bank account and I have positive $2, we're in a different situation from each other. You are negative money, you owe somebody money, and I have money. So positives and negatives are not the same like that. So if I can't pull matching, x's off each side, I've got to eliminate a different way. So for each negative, I'm going to include a positive. So I'm going to add, for every negative x, I'm going to add a positive x. So on the left side, I added 7 positive x's. Whatever you do to one side, you have to do to the other. So I'm going to add 7 x's over here. I'm sorry, 6. Whatever you do to one side, you do to the other. Now, if I go over to my equation, I'm just going to write down what I did. I added 6 x's to the left, and I added 6 x's to the right. Now, you may be able to look at this and figure out, what the left side and the right side looks like. If you can't, let's see what happened over here. These are each going to cancel because a positive and a negative combine to make 0. So those cancel. And over here, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positive x's. So on the left side, all I have are 7 negatives. Remember, the hanger balance is on an equal sign. On the right side, I have 10 x's and the negative 2. So I've got all my x's on the right-hand side. Now I need all my numbers on the other, because remember, the goal is to have a variable on one side and a number on the other. So I need to eliminate these 2 negative 1s. I have 2 options. I can actually take 2 negatives from each side, right? So I can remove 2 negatives from each side. The only problem with that, and I'm not going to rewrite over this. Let me show you for a second. If I were to think about this as removing 2 negatives, it would look like this: minus negative 2, minus negative 2. I don't know about you, but 7 minus negative 2, I don't necessarily trust myself to get the right answer to that. Negative 2 minus negative 2, I don't necessarily trust myself to get the right answer. We have a couple options. Subtracting a negative is like adding the opposite. adding the opposite. So you may have to do a little bit of work so that you're getting correct answers, because this could be a point where you know exactly what you're doing and then the positives and negatives mess you up. Again, that's an option, but I'm telling you right now, if you try looking at this subtracting negatives, it starts getting kind of messed up. So if it was me, here's how I would look at this. If I know I need to eliminate these two negative ones, I would combine it with two positive ones, because those also cancel, and these will also cancel. And if we look at the work, all I did was add 2 to the left, add 2 to the right. And on that other example, when I messed with the subtraction sign and made it plus positive, it was adding 2. So be very careful. The other thing you might notice, if you didn't already, see how I had a -2 or -2? The opposite of -2 is +2. So the hanger may have overcomplicated sometimes, but if you look over here, it was a -2 and I combined it with a positive. So -7 + 2 is -5 equals 10x. And if you look at the hanger, I have 10x on the right and I have 5 negatives on the left. So our last part, I'm actually going to redraw this just so that you can see a little more clearly. So over here, I've got 10 x's, and on the left side, I have 5 negatives. Now the thing is I need to figure out what 1x equals. I don't want 10. So I eventually want it to break down into what does 1x equal? So eventually I want it to turn into this, where I just have 1x. So if 10x's equal -5, what's 1 going to equal? Now, if we think about the hanger, I can't really match up 1x with a negative, because if I did that, I would have x's left over. I actually have, if I were to group, I would group, sorry, I tried to add like an arrow, but I would have to group 2 x's for every 1 negative. Right? So I would have, if I wanted to try to group these together, I would have 2 x's with every -1. So if we think about that, for every 2 x's, I get 1 negative. So what do you think would happen if I broke this in half? 1x would equal half of a negative. Now this is where the hangers, when we get into more advanced equations, these hangers may not make life easier. However, what I need you to do is think about the process that we're doing. Once I had x's on one side and numbers on the other, then we started looking at dividing things up and breaking into groups. And dividing up and breaking into groups is multiplication division. So if you notice, we added and subtracted first to kind of rearrange. And once we rearranged, then we grouped. That's a very common process. If you look at our equation here, we added and subtracted, and now we're going to start grouping. So if I want to break, and again, it doesn't work great with the picture, but I want to break these 10 x's into 10 groups. Breaking into 10 groups is just dividing by 10. My 10s cancel and I just have x. And on the left, I have 5/10. 5/10 simplifies to 1/2. Negative divided by a positive is a negative. Now here's the thing before we move on to 2. When we're solving these equations where we have an x on both sides, numbers on both sides, you could have actually picked any part to start with when it came to the rearranging. So, like if I go back to my hanger, I started out by adding 6 x's on each side to get rid of the x's here. I could have gotten rid of the x's on this side. I could have handled the -1s, or the 7 negatives or the 2 negatives. So I'm going to show you this equation completed or solved a second way. You don't have to copy this down. I just want you to watch. So let's say you wanted to eliminate these x's first. For whatever reason, you thought that looks good. And if you think about the hanger, all we would be doing would be canceling out the x's on this side. So if I want to cancel out 4 x's, 4 positive x's, I'm going to combine it with 4 negative x's. So if I'm trying to eliminate this piece, I'm going to add the opposite of it because 4x and -4x make 0. So I'm left with -2 on the right. On the left, I get -6 and -4, which is -10x minus 7. Now I want you to look at the difference of what we have between our 2 methods. Let me zoom out a little bit. Here, I ended up with -7 equals 10x minus 2. And down here, I have -10x minus 7 equals -2. Now, I'm going to tell you that I like this way better because my x's stay positive. My x's down here are negative, and even though we can handle it, sometimes it feels a little bit more comfortable sometimes to not have to deal with negative variables and things like that. So kind of keep in mind as we go through and solve these, see if you can figure out how I'm picking the x's to eliminate first. Just kind of keep that in the back of your head. So if I kept going, I now got all my x's on the left, so I want to get my numbers on the right. So I have 7 negatives here. So imagine my 7 negatives hanging. To eliminate the 7 negatives, I'm going to place 7 positives. So I have my -10x on the left. -2 plus 7 is 5. So I have the 10 negatives, the 10 negative x's that I want to break up into groups. Because remember, once I have variables on one side and numbers on the other, now I'm going to start grouping them, breaking them into groups. So I would have to break this into 10 negative groups. 5/10 is 1/2. My fraction starts negative, so I've got to finish negative. And if you look, I got the same exact answer for x. So you could have chosen any of these 4 pieces to remove from that side of the hanger first. It's up to you. Okay, for number 2, zoom out a little bit. For number 2, we've got a fraction that showed up now. So to handle this, we'd still have 2 options, at least. And I'm going to show you both, but the one that I do right now is the one I want you to copy. What we're going to do is we're going to eliminate the fraction. Okay, and it's actually, technically it's called clear. You'll hear people say clear the fractions. That just means get rid of the fractions. Okay. So we're going to clear that fraction. So in order to do that, if you look at this, my left side here is being cut in half. So the 7x minus 6 is being cut in half. To undo something being cut in half, you double it, right? Another way that you can look at this is I want, on this left-hand side, if I want this fraction gone, if I can turn that 1/2 into a 1, 1 times 7x minus 6 is just 7x minus 6. So I've got to think of a way to what I can multiply by 1/2 to make it become 1. What do you think can be multiplied by 1/2 to make it 1? 2 over 1. 1/2 times 2 equals 1. If I double something that's cut in half, I have a whole. A number times its reciprocal always equals 1. Okay, the reciprocal is when you flip the fraction. Okay, so we're going to multiply each side by 2. Now you'll notice I put parentheses around the 6x minus 10, and that's because everything needs to be multiplied by 2. Now if I multiply the 2 times 1/2, technically that ends up multiplying everything. So on the left side, my 2's cancel, and I get 7x minus 6 equals 12x minus 20. So now we're to the point where we have variables and constants on both sides. So I have variables and numbers on both sides. So I want to start getting x's on one side of my hanger together and constants on the other. So I like to start with the x's. You have more control as you work. So if you imagine I have 7 positive x's on the left, I have 12 positive x's on the right. I'm going to handle these 7 positive x's. If I have 7 positive x's that I want to eliminate, I'm going to remove them, or I'm going to pair them up with 7 negatives. 7 positive, 7 negative make 0. Whatever I do to one side, I have to do to the other, right? I get negative 6 equals 5x minus 20. 12 plus negative 7 is 5. So now that I got all my x's to the right, I want to take this constant and get rid of them on the right so that I have only numbers on the left. So if you can picture the hanger, I've got 20 negatives on the right-hand side, so I want to get rid of them. So the best way to get rid of the 20 negatives is to add 20 positives. So on the left-hand side, 6 negatives, 20 positive is 14 equals 5x. Now again, I'm not going to draw it because it isn't going to look very pretty, because I have 5 x's on one side and 14 units on the other side. But if we can imagine what we would do, I would want to break up this left side. I'd want to take those 5 x's and group them in 5 groups, because if I group the 5 x's into 5 groups, then I have 1 x in each group. Well, if I break this side into 5 groups, I've got to break the other side into 5 groups. And I get x equals 14/5. I'm going to pause for a second here. So you may feel like you wanted to distribute the 1/2 first. And sometimes that will be an acceptable first step, and sometimes it's even the best first step. But if we take a look at what would happen if we distributed, 7 is not an even number. So when I distribute my 1/2, I'm going to get 7 over 2. Now the 6 over 2 simplifies to 3, but my 7 over 2 does not. And if I wanted to continue solving, now I'm dealing with 7 over 2 x's that I've got to do something with. And it's possible, and it's good to practice your fractions. It's a really good challenge if you feel like this is easy. And if you want to see this done, let your teacher know, but I would avoid this if at all possible. You have control over the choices that you make when you're solving. And so part of this is making good choices, and distributing the 1/2 here, probably not the greatest choice in this case. All right, let's look at number 3. So now number 3 is a little bit of a different situation, because now we actually can't avoid a fraction if we just start solving this equation. So if you wanted to go through and start solving this equation, you're looking at adding or subtracting with halves. So if we think back to what we did up here, we multiplied each side by 2 so that we could clear that fraction. We can actually do the same type of thing on number 3. I can actually clear this fraction. So if we think about it, if I want 1/2 to disappear, that means I want it to become a 1. To make 1/2 become 1, I multiply it by 2, right? But you have to remember, when we're multiplying on both sides, we have to multiply everything because the whole side gets doubled. So I'm going to multiply everything on the left and on the right by 2. So everything gets multiplied by 2. Everything on the left, everything on the right. And what's going to happen is 2 times 1/2 is just 1. 2 times 7 is 14. On this side, let me show you this. 2 times x is 2x. 2 times 13 is 26. Now again, you don't have to do it this way. You could have, negative 1/2 x on each side. But if you have the skills to clear out that fraction, which you do, you should use them. So now we've got to start rearranging these hangers. So I'm going to eliminate the 1x on the left. If I have 1 positive x, I'm going to combine it with a negative x. Whatever I do on the left, I do on the right. And you get 14 equals 2x, and negative 1x is just x. And the 26 comes down. Don't forget these pieces that we have left here. And also don't forget the sign. If this was a minus 14, you would have to bring down a negative 14. So be very careful. So now I have my variables on the right. I need to get my constants to the left. So if I have 26 positives, I'm going to combine it with 26 negatives. Positive 14, negative 26 is negative 12. On the right side, my 26's cancel, and I get x equals negative 12. Now again, when you're solving, you could have chosen, You could have added negative 14 to each side. You could have added negative 2x to each side, negative 26 to each side. And I would suggest, if you have room, that you try solving this, maybe choosing a different number instead of, the x, and see if you still get the same answer as me. All right, last one, number 4. So for a problem like number 4, again, we have options. Okay, option 1 would be to simplify each side. So we could start out distributing. And we're actually going to do this 2 ways. So make sure that you don't fill up the entire box here, because we're going to do it a second way underneath. So the first thing we'll do is we'll distribute the 2. That's how we'll start this out. So I get 2x plus 14 equals negative 4x plus 14. Then I'm going to choose one set of x's to get rid of on one side. I'm going to pick the negative 4x. So if I wanted to remove the 4 x's on the right, I'm going to combine it with 4 positives. So if I want to remove the 4 negatives, I'm going to combine it with 4 positives. So on the left side, 2x plus 4x is 6, plus 14 equals, those cancel, and I'm left with 14 over here. My variables are on the left, so I want to start taking this positive 14 and get rid of it. So if I have positive 14, I'm going to combine it with a negative 14. I have 6x on the left. These are eliminated. 14 and negative 14 is 0. Now at this point you could stop, because you could look at this and say, well, the only thing x could be is 0, because 6 times 0 equals 0. But let's say you didn't really see that yet. So we know that we have 6 x's on the left that we want to break up into 6 groups. 0 divided by 6 is 0. Now I am going to have you complete this a second way. So underneath it, let's rewrite. Now this second option, if you think back to number 2, we eliminated this 1/2 by multiplying by 2. And that eliminated any distributing to do. I'm going to use that same type of tactic, the same strategy on number 4. I want to eliminate the 2. So to eliminate that 2, I'm actually going to multiply both sides by 1/2. Now really what this ends up being is it's like a big fraction. Let me rewrite this. It's really like I'm dividing each side by 2. If I have 2 being multiplied on the left, I'm going to undo it with division. So you could look at that either way, multiplying both sides by 1/2 or dividing everything by 2. So what happens is 2 divided by 2 makes those disappear. And I actually don't need that. And if I divide the right side by 2, negative 4 divided by 2 is negative 2. 14 divided by 2 is 7. So that actually makes this a pretty simple from here if we wanted to. I'm going to eliminate these x's on the right. So negative 2 x's, I'm going to combine with positive 2. 1x plus 2x is 3x. These cancel. Remember, if we look at the hangers, it's like I have two negatives and I combined it with two positives. So I have 7 left here. Then I want to eliminate the 7 singles that I have on the left side because I already have x's, and I want to remove the units. And I'm left with 3x equals 0. We're going to stop here because this is the same type of situation as 6x equals 0. And that's it for that side. Make sure you rewind and get any parts of these equations copied down that you need. Make sure you ask questions. Look through the steps and make sense of what was done each step. And if you can't, put your hand up and get help. Go ahead and look on the back side of the lesson 5 notes. Okay, so 5.3, a puzzling puzzle. Tyler says he invented a number puzzle. He asks Claire to pick a number, and then he asks her to do the following. So go ahead and we're going to pick, triple the number, subtract 7, double the result, subtract 22, divide by 6. Claire says she now has -3. Now what you can do before we move on is if you want, over on the side somewhere, pick a number and go through those steps that Tyler has in his puzzle and see what you get as your answer. Pick a second number. Go through those steps, see what you get as your answer. Because if you take a look at what your result was and what your original number was and what Claire's result was, you might be able to figure out what process happened. Okay, so for example, I'm going to pick the number 10. So triple the number, I get 30. Subtract 7, 23. Double the result, 46. Subtract 22, 24. Divide by 6 is 4. Now I want you to go off to the side and I want you to pick a different number. So everyone's going to do this. You pick a different number and I want you to go through the steps and see what you get as your final answer. And I want you to take a second and compare my original to my final, your original to your final. See if you notice a pattern. If you don't, maybe try it one more time. So hit pause, and I want you to go through, choose a number, and go through the steps, and see if you can determine how, if there's a pattern to how the original and the new number have a connection. So pause there and then come back. All right, so if we go back to the question, it says, Claire says she has -3. Tyler says her original number must have been a 3. How did Tyler know? Explain or show your reasoning. So hopefully you took a look at the final and the original, your final, your original. And if we look at Claire's final was -3, and Tyler says her original must have been 3. You can go through and double check that he's right, but I can tell you he is correct. Her original would be 3. You figure out how that happened. Now, you can't just say, well, the original is blank compared to the final. Like, the original was 6 more than the final. So if you take the final number and you add 6, you get the original. If you take the final number and you add 6, you get the original. That's true, but we're going to take it a little bit further. So I want you to come up on your own with another way to explain or to show how did that work? Like, why is it that the final answer is 6 less than the original? Okay, so hit pause, and on your own, you're going to determine how to come up with the original, or the original if you're given the answer. Or how did Tyler know? Explain or show your reasoning. So hit pause and try that. Okay, hopefully you came up with something on your own. Maybe you came up with an expression. So maybe, for example, you went through and you said, okay, we don't know the original, so I'm going to call that X. So maybe you triple the number, then subtract 7. Then you double the result, so this gets doubled. Then you subtract 22, and the whole thing is divided by 6. And that had to equal -3. So, I mean, you could have gone through and, made an expression or made an equation. At the bare minimum, you should have written that Tyler added 6 to the final result. Or you could say the original minus 6 is the final answer. And that's it.